Hello, and it's been a while. Today we are going to be doing some LibreOffice calculation together with the Devil's Calculator. How have you been? Today we have stopped at level 27. Okay. Now, what were we doing? We were working with the function psi for Gangnam Style. Okay. How did this thing interact with something? Let's try. I want to try the following. I want to try on the left side, we're going to go through the numbers 1 through 10. And on this side, we are going to go through only the 1. Can I just do this? Yes, okay. Let's try this. So, 1 psi 1 1. Okay. 2 psi 1 3. Okay, this looks like addition, and the first one looks like a Boolean operator. So if the two are equal, then it will give out a 1, or maybe it will just give out the equal, a value equal to the one we inputted. 6, okay. Let's see for 4 and 1. 12? No, 10. Okay, 5 and 1. 15. Yeah. This looks like if you sum up. Okay, first of all, let's do a hypothesis. I think it's going to continue like this. Yeah, I think it's going to continue like this. So let's check this. I can't check the one 6 to 1, so let's go for 7 to 1. 28. Let's go for 8 to 1. 36. Okay, and 9 to 1 for yeah. Okay, so this. Let it seem like. Can I want to now try something new. Okay, we can actually work with. Okay, we can actually work with this. Can you see this? Yeah. Okay, we're going to write this like this. We have a sum from I equals x to y equals to n equals y, and we sum up a function of I. So what does that mean? This little function means we sum up every single number, every single positive whole number that is between the number, this number, and this number. At least this is the first look that this is giving us. To check whether this works the way that I think it does, we are going to now check it for symmetry. So let's just mirror things like this, and normally what I would expect is that we get the same thing plus minus a connotation, a positive or a negative one. So let's check. So 1 to 1, we obviously this is a 1. Then 1 to 2, 3. Okay. Obviously, I'm too lazy to do this for every single one. So let's go for 1 to 4, 1 to 7, 1 to 8, and let's just go for one really high one. 20. 210. Does that fit? 20. I don't think so. This is a little too low. Or maybe I'm mistaken. So, well, 1 second. Can we do this equals the sum of B1 to be 40. Okay. Not B. Okay. Yeah. What I'm trying to do is I'm too lazy to check whether this is true. So instead I'm going like this. Next I'm going to continue this little line until we're at 40. Since this seems symmetrical, I can ignore the rest. So now I'm going to get rid of a 40 and make this a 21, I think. 210. Okay, this hits. Okay. Sometimes you have to check whether the formula that you've predicted is actually true for higher numbers. This is what I was trying to do. So if we have a difference of 1 and 20, so a difference of 19, then we will get a 210. That is what I'm expecting. This formula, however, is not what I just said what I'm expecting. It's not the same as what is standing right here. So let's check what's the truth. Right now I'm going to try out a new row, which is going to be, I want to get rid of all this right here. Nope. Thank you very much. We are going to start off at the 2, and that is 1 until... No, we're going to stay at 2. And this is going to be static. We're going to go for start by 0, 1, and let this continue until 12. Let's check out what this will give us. 2, 0. Already interesting. Is this interesting? This is the same as if we were calculating 1 plus 2. So if we have a difference of 2, okay, yeah, this makes, can I, okay, I can, by double clicking. So what I'm expecting now is 1 x minus abs of x minus y to y minus abs of x minus y. So currently I'm expecting this to be the formula. Can I make this bigger so that it's not this can I somehow make this bigger? This is just a little original size. Okay, thank you very much. And now I would like to make this align objects, arrange, position and size. Keep ratio, and let's make this bigger. Okay, so now you can actually read what is standing there. So I am expecting, what this basically means is we get two numbers, the left one and the right one. We check the lower number, we subtract the difference, and then we start to add all the numbers in between until we have a desired sum. So what I would be expecting, if we say take 7 and 4, the lower number is the 4. So what I would be expecting is we do 1 plus 2 plus 3, and we would be getting a 6. If I don't have any mistake in what I'm thinking. So this should be a 6, but it's not. That's not good. Okay, then we will get back to this theory once we get a little more information. But let's remember this just in case it comes up again. So where were we? Let's get rid of this. 2, 0. 2, 0 has been a 3. 2, 1 has been a 3. Okay. That's not good. 2, 2 has been a 2. Really not good. Well, this one we expected. At least I expected it. So if we go x, we will get another x. So in theory, this is why the 666 doesn't work. If we had inputted 666, so for example 888, 888, we would have gotten 888. So that's the idea behind why we can't do that. But this still confuses me about how the function looks. Okay, so 3 to 5. Did I miss a step? No, I didn't. Is the next one going to be an 8? 2, 4, 9. Okay, 9. This looks almost like a parabola, but no, it doesn't. This has a difference of 3. This has a difference of 9 and of 4. This has a difference of -1, however. No. So 2, 3, 4. Another hypothesis could be that this is a difference of 5 now, so 14. So let's check 2, 5. Maybe this is a recursive formula. f of x, y, f of x, y equals f of, and I hope I'm correct, this would make things easier, x, y minus 1 plus y. This might be it. Plus f of x, y, x equals x. This could be the definition of a recursive formula. So let's make a quick recursive tree. 1 second. Let's go for 4, 6. What I would expect would be 4, 5, 4, 4. This would be a 4. This should be a 9, and this should be a 15. Under this, I can't check that last one. Okay, 9. So let's instead go for 4, 7. 4, 7 would be a 22. Am I correct? Come on. Okay. This means I understood what this does. So what did I just say? A recursive formula is a formula which, in its terminology, in itself, explaining itself, opens up another copy of itself with different inputs. So let's just play this through with what I was doing right now. With the formula that you have left to what I'm writing right now, f of 4, 7 equals f of x stays the same, so 4, y minus 1, so 7 minus 1 is 6, plus y is 7, so 7, and this equals f of, once more, 4 stays the same as the input, 6 minus 1 is 5, plus 5, and now we need to do, no, not plus 5, plus 6, because that was the 6 we just inputted right here, plus the 7 we inputted earlier, because that plus 7 won't just disappear. And this equals, let's go down one more, f of 4 plus 5 plus 6 plus 7. And this would equal 4 plus 5 plus 6 plus 7. So basically this just looks like we add up, well, this looks like we add up just the numbers we just had and add them up together. So maybe I'm mistaken, because if that were the case... okay, well, we're going to do the following. I'm going to write down a 1 right here and a 2 right here. We're going to expand this thing to, let's say, 80. This is going to be way too much. I just want to try out some things. We are going to go for sum of a 29 to a, and I think I need to do a $, 29 to A29. And I think I need to do this in captions. No. Let's try this again. Sum of... Okay, I got a mistake. Okay, now it works. Okay, now let's check if this works properly. Okay. So this table is going to be us summing up every number from 1 to from 1 to, for example, 2 in this one, from 1 to 7 in this one. So we have a table of the function sum from I equals 1 to n equals the row we are in right now, seen from beginning from here. Now, what I want to do is not only this one, but I want to do the same thing from here. So I want to write this equals the sum from this, and I will do this in dollar signs, to this, and I will do this once more. No, this deletes the contents. Can it still work? Come on. It does work. So this is the same as this. Okay. And we actually have a 666. So if we go for 1 to 36, this would work, but it's not quite what we need. I think I'm making it too hard on myself. So let's just say f of x, y equals 666 equals f of x, y minus 1 plus y. How many would I need to find out what equals 666? Too many. Instead, I would like to have one solid one. I would like to have one thing that is actually where I don't need to change anything. So let's just say f of 30, let's say 20, y equals 666 equals this is equivalent to f of 20 y minus 1 equals 666 minus y. This one also has 162. Does that help me at all? I mean, I could now, if you don't know, let's quickly go for OLE object, formula object. If you have a sum from I equals 0 to n over I. This is the same thing if you multiply this by using 1 minus I, no, 1 minus, yeah, I think 1 minus I over 1 minus I, you will, if you multiply this to the sum I had before, you get no, what I'm making, this is a geometry, this is wrong. No, forget what I was saying before. This isn't quite what I want. I'm thinking, so first of all, I know what the answer, how you can write the sum that I just wrote down. You can write that is equal to n square minus n divided by over over 2. I'm pretty sure that's what it is. But that's not what I'm doing right now. That's not what I want to do. Let me think about this. Give me 1 second and we will talk once more. I just had a thought which I've been thinking about. Right here, the 36 number is from the sum that I have plotted, that I have written in a table, would be the 666. So if I were to write, for example, 0 to 30, 0 to 37, I would get 703, which is 37 over 666. What I've been thinking about is how to plot this 36. And what about if I go for 0 to, and then I write this 36 as right here, 0 to 8. 0 to 8. Or, okay, maybe this is from left to maybe this is read from left to right. This would mean that if I write 0 to 8 to 0, I got the 666. Okay, this one table that would have been enough. There was another method to do this, which I could have done, or I could have tried, is try to express this recursive function, which I've written down right here, as a, at least I think it would have worked, as an exponential, as a potential series, and I would have tried to create, to find the creator function of this series, and then try to calculate, reverse calculate the thing that I would need to input 666 to get an output of 666. I don't know if it would have worked. I just had I've done something similar with recursive functions before, but I've never tried this. There were different circumstances there. So 1 level until now. How much time do we have spent? Come on, this is going to be a longer episode. It's been a while. Okay, let's check out 0, 0. Okay, that's a good start. X, Y, 0, 1. Let's expand this. Let's go for 1, 1, 1. Let's expand this. Let's go for X, Y, 1, 1. Expand this, and let's go for 0, 1, and let's expand this. Okay, this should be the information we need to start with. Okay, 0, 0 we already know. 0, 1. And I made a big mistake. Can I shift this 1 over? Maybe 1 more. Okay. Now we actually get the equals. No. How would f of x with y? Okay. Now can I just slightly have a background color? Gray, 100%. Let's go for gray, 91% maybe. Okay, and this one is going to be rose, maybe. I just need to have a basic difference so that I can look at this a little easier. Okay, so 0, 1, okay. Oh, 0, 1 is 0.5. And why did I start with, whatever, 0.5? Okay. Where do you get 0.5? Okay, let's just take this as at face value, and let's go for 2, 1, 10.5. Okay, let's check for 4, 1, 4, 1, 20.5. Let's say 30.5. No, it's not 30.5. This is going to be 35. This is going to be 35.5. At least that's what I'm expecting. Oh. Did I skip something? So 0, 1, 2. Okay, I don't. Okay, let's get this over. 1.2. Okay, I'm confused now. So 2, 1, 0, 1. Okay, now I'm completely confused because I confused myself. So let's get rid of this. We're going to go through this once more. 0, 1, 0.5. Okay. 1, 1. 5.5. Okay. 2, 1. 10.5. Okay. 3 isn't possible. 4, 1. 20.5. I'm expecting this is a 15.5 and this is a 20.5. Okay, what was so difficult about this? I don't know. Let's say... So we go up by 2 if we go up, so let's just say this one should be a 80.5 maybe? Can this calculate it? Okay, so 10, 50.5. Yeah. Okay, so this looks like so this set of data says that f of x1 equals 0.5 plus 5 times x. So this is what we expect our function to be. I'm also going to change the font color to green. This isn't, yeah, okay, this is green. So this is what we expect. Let's check the next set of data, this one. This is basically checking for symmetry. Is our function symmetric? So let's go through this once more. So we go for 1, 0, 5. 2, 0, 10. Oh, I'm... Okay, no, once more. 1, 0 is 5. Okay. 1, 1 is 5.5. Okay. 2, 1. I have made the same mistake again. 1, 2, 6. I'm very confused. Now I'm expecting a the 1, 4 to be a 7. Okay. So right here I'm expecting f of 1y equals 5 plus 0.5 times y. Just checking. Yeah, also this is a 6.5, this is a 7. This is a 7. This is a 7.5. Okay. Now, I'm also going to, can I underline this? I can, and right here as well. Next, what do we need? What more do we need? Let's check for 2. Let's check for 2. So 2, 1, 2, 3, like this. Okay. Once more. 2, 1, 10.5. 2, 2, 11. 2, 3, 2, 4, 12. Okay. now we got something. Okay, 2, 2 was 11, 2, 4 was 12, and 2, 3 is probably, no, 2, 4 was, yeah, 2, 4 was 12, and this one is 11.5 probably. 2, 1 was 10.5, yeah. Okay, and just in case 2, 0 is 10. Okay, so this one also seems like f of 2y equals 10 plus 0.5 times y. And if I look at this, this seems like f of xy equals 5 times x plus 0.5 times y. Did I make this in the correct order? 5 times x, 0.5 times y. So I am expecting that if I... where am I? Okay. I am expecting that if I input... let me quickly think about this. 3, 8, 12, 0, and I should be getting a 60. If I just if I didn't miscalculate. 12, 0. Okay, yeah. So if I instead input a 120, and then I would be getting a 600. And if I inputted a 132, then I would be getting a 660. But I can't input the 132 because of me not being able to use the 3. But if let's just continue like this. If I inputted 133, then I would be getting, let's say, 0.2. 133.2, I would be getting a 660. Instead, I'm going to get rid of this and increase this number by 2. Now I need to get this to 29, so I decreased this number by 4, and I should be increasing this number by 40. I just made this out of the top of my head, so I don't know if everything's correct. Okay, it's a little too high, and it is a lot too high. Let me check this once more. 129, 0, 645. 129, 1, 645.5. Okay, 129, 20. Why is this suddenly so big? This is way too big. 129, 10. Again, way too big. When does it suddenly happen? Okay, let's continue like this. For now, I'm not going to do anything. For now, let's just continue like this. We're just going to input 129, and then, for example, where were we? 10, so let's go for 12. Suddenly this happened. 129 and 11, 6455.5. Okay, this is interesting. Something weird has happened. Can we graph this? It's probably not possible to properly graph this. Nah, this is completely nah. We can't use the graph function here. Plot, maybe? Do we get a good... Nah, this is full. Ah, no. Okay, so what's the problem? Basically, right now, if we input the y value, will diverge from a... Until now, the y value increased the function output like a polynomial, in polynomial growth. but now it seems like there's a threshold where the y value will skyrocket. So let's continue, let's go back to 0, 1, this is 0.5, 0, 12 is 6, also correct, 0, 20, also correct, 0, 100, 50, okay, let's go for 1, 100, this should be 55. Aha. This is weird. So what just happened? This isn't what we would expect to happen. Why? 555. So my expectation, if I now increase this to 2100, I will get 6000. No, 1050. Okay, so now this increases the entire thing by 100. So, okay, we need to... what is the smartest way to do this? First of all, delete everything. Make everything white. And make this entire thing gray. This entire thing gray, and let's make this thing say 1. This is x \y. This is 2. And we're going to go for at least 39. Now we need to make this a little smaller. Maybe even smaller than this. 1, 2. Until now I have been using tables which were one-dimensional, now I'm using a two-dimensional table. Maybe I should have started by 0. It's fine. I need a little more clarity, that's why I need to do it like this. So this is a 5.5. Okay. So in y direction, this is the y direction, I get a 6. 6.5, 7, 7.5, 8, 8.5. Let's just say we continue a little bit and let's check out at 118. I get a 59. So somewhere along the way something happened. 55. Let's check out 19. Yes, this is the last expected value, 9.5. Right here we get something else. We get a 55, correct? 55, yeah. Now, what's that 111? 55.5. And it's going to continue like this, so let's say 56, and we're going to continue like this, and my expectation is that we're going to continue until we are at 19, and now something should happen so that we get, okay, let's check this out. 119, 59.5, 120, 60, okay. Okay, so my next expectation is if we input 1 and 100, 550. Is that realistic? 100 would be 50. Yeah, this is normal. So why did this jump suddenly happen? If this is explainable by a formula, this is fine. But if it's not, then it means that we are we have an irregular function. So until now, in lower parts of the function it works properly, but in higher parts it doesn't. Let's just go into the other direction. Let's say to 1, 10.5. And let's expand this and check where it stops to work. Let's say 10, once more. 1, 10, 55. No. Why? 1, 9, 9.5. my mistake. 9, 1, 45.5. Okay, that's proper. 10, 1, 50.5. Okay, no, that was just my mistake. So let's just say, for argument's sake, 101. 500.5. So this function behaves completely normal, and I could select all this and drag this out into infinity, and it would still work. Okay, let's check out the 1, 2 thing. 1, 1, 2, 6, 2, 2, 11. 3, 4, 2, 21. So 16, 21. Let's expand this a little bit. So the expectation is that 32 and 2, let's say 28, 27 and 2 should go for 136. 27. Yes, okay. 6.5. I think this is mostly expected, so let's expand this. Let's expand this like that. Can I expand this like that? I think yeah. This set of data seems pretty full. So let's check 23 and 7. I can't. Let's check 22 and 7. 113.5. I might have made a mistake somewhere with oh, this is 21 and 7. Okay, yeah, this is fine. 21 and 7. Okay, 108.5. So now there should be a point where this auto scaling from LibreOffice doesn't work. So until now, if I check 22.9, I should get 109.5. 22, 9, not 0.9, but again, I seem to have made, yeah, again, this is the same mistake I just made. So this is 21.5. Okay, so everything's fine. The table I've made until now works. Now we get into the weird thing. So let's input 2, 10, 105. This doesn't make any sense for now. Let's check out 22, 10, 1105. Honestly, I don't even need to necessarily finish this if I can make this string work. But I think right here there was a jump in the function, and now, if I'm correct, I should be getting this right here at 21 and 13. So, yeah, right, 13. Okay. I'm going to do the following. I'm going to try and input 13 as a 2 and a 6. 2, 6 is a 13. Okay, 2, 6, and 21. I made it, okay. 21, 2, 6. And the problem lies in the problem right now we are having lies in the fact that we are using this calculator goes from left to right. I can't use any parentheses. I think I can't use any parentheses. Okay, instead of trying to solve the formula itself, I could be trying to just expand this, and at some point I should be getting a number which should work well enough. You know what? Let's try that. We don't always need to be that non-lazy. 664, 600, somewhere along the way something... Yeah, no, this is correct. 665.5. So 322. Okay, I also see the problem right here. Let's say, okay. If I were to input 665 point... If I were to input 321 and then a 2, then I would be getting the number that I'm looking for. So f of 321 and 2 equals 666. Because right here I get 665.5, and if I go 1 to the left I would be getting 0.5 more. Okay, so all I need to do is plot the number 321, because I can write this from left to right, and I don't need to look at the part of the function that is going astray. 321. Where is it? 321 right here at 64 and 2, I think. So 64 2 322. Okay. 64 to 21, was it? No. 64 to 2. Now I'm confused. So first of all, 64 2 works. 321. But why does the part where I input the number not work? Maybe because why did I think about 321? Why did I get to the number 320? Because it's the... No, it's I was correct. That should be what happens. Okay, maybe we check whether this sequence into the x direction breaks up at some point. So let's check 276 to 1. Yeah, it breaks up as well. So let's check out 231. I can't. Let's check out 86 to 1. 430.5. Okay, I was off by 1. Okay. 430.5. And if I go for 86 to 2, I get 431, so this still works. If I go for 159, 158 right here, to 1, 790.5, something happened. Right here, something happened. Let's check out 105 to 1. 521. Yeah, again, something happened. I don't know what exactly happened. So maybe exactly at 100 something happens. So 99 to 1, 495 to 0.5 should be what's inputted, what's outputted. I am very confused about... okay, first of all, what I have right here seems to be wrong, but I don't know. 5... Normally I would expect... Oh, do you see what I'm seeing? Somewhere the sequence didn't properly work. Right here it's proper, but right here we are suddenly getting increments of only 1. Okay, this is what happened. Then I can just solve that problem by doing this once more. And once more. Okay, so the reason why the sequence suddenly broke up is because LibreOffice apparently has a problem with two big numbers where it won't properly do the automatic algorithm to expand the thing you want to expand. Alright, this means a little bit of an easier time. We're just going to delete the things we just had, and I think not bad. We just need to go up to, where is it, 666, right here, 135 and 2. This is a lot smaller. Okay, 135. Where do we have 135? 135 is right here. Not quite. I did say 135.N2. Oh, sorry, that was really loud. So what if I input 26 and 9? Okay, I can't do that either. I see. Okay. In that case, what about 140? Is 140 better or 130? None of those are really good. Okay, let me think about this once more. 1 second. Okay, I have thought a little bit about this. So, first of all, I need to get to 133. So 133 and 2 should equal 666 as an output if everything I've done seems to be correct, which I'm hoping for it to be. Next, how do I get to the here? Which inputs do I need to get to 133? I just tried this, as you can see on the screen right here, with in red on the Devil's calculator. I've just checked where are we the closest to being at 133? Right here, to be honest. So let's check this out. So if I write 210, this is a 105. If I write 211, this is a 105.5. 105.5. And if I expand this series, until right here, and I expand it a little more. Well, if I were to expand this a little more, so let's just say 220, 1010, 250, 125, 260, 130, 2 right here, 66, 133, and now 266, 2, and we get a 666. How long have we been here? 53 minutes. I think today is going to be enough. We've gotten finished with 2 levels, and next time I hope we're going to do this a little quicker, a little more working with tables. I do like that. We're working with tables now. This makes thinking a little easier, and I would say have a nice day and goodbye.